Compound interest differs to simple interest in the way that you actually earn or get charged interest on top of the interest. So it goes off your current bank balance rather than, or your current balance, I should say, rather than staying as the same amount every time. So we have a new formula, and this time this formula actually gives you the final amount rather than just the interest. So if you're looking for just the interest, you'll need to do the final amount, take away the starting amount, and that will give you the interest. So our new formula is A equals P times, open brackets, 1 plus R over N, close brackets, to the power of N times T. So A is obviously the final amount, P is your principal, just like in the simple interest formula. R is the rate, and again, it goes in as a decimal, so 5% goes in as 0.05. And then we've got N, which is the new one. N is the number of compounding periods. So it's how many times you're going to get this interest over the time period. So it could be, if it says it's monthly, then it's 12 compounding periods in the year. If it's weekly, there's 52 compounding periods in the year, etc. And then time is your time in years. So our first example is $4,500 is borrowed at 3.2% per annum, compounding annually for 5 years. How much is owed after 5 years? So again, I just always write down the side what I need. So A, we don't know. The principal is 4,500. The rate is 0.032. T is 5 years. And N, how many compounding periods? Well, it says it's compounding annually, so that's just once per year. So we would have A equals 4,500 times 1 plus 0.032 over 1 to the power of 1 times 5. Now, it is really important that when you're doing these questions that you actually work out, especially on a scientific calculator, that you actually work out that power, what that equals first, or you put it in brackets. On the Casios, it's not so bad because it will do it for you. But yeah, just on the scientific ones, you need to make sure you have the brackets around the power, or you work it out first. So once you pop that into your calculator, how much is owed after the 5 years? You would owe $5,267.58 to the nearest cent. The second example is if $2,700 is invested for 4 years at 2% per annum, compounding monthly. So I'm just going to underline monthly there. How much interest is earned? Okay, so this is a little bit different because the last one was asking how much is owed. So that's asking for the final amount. Whereas this time, this is only asking for the interest. However, we still do these things the same. So A, we don't know. Principal is 2,700. The rate is 0.02. Time is 4 years. N, I underlined monthly before. N, there would be 12 compounding periods in a year. And I'm also just going to pop down here I, because that's what we've been asked to find. So then we put into our formula 2,700 brackets 1 plus 0.02 over 12 to the power of 12 times 4, which gives you $2,924.68. So that's our final amount after the 4 years, but it actually asked us for the interest. So to do the interest, we would do our final amount, $2,924.68, take away 2,700. So the interest earned over that period was $224.68. And that's our final answer for that one. Last example, if $5,000 is borrowed at 3.5% per annum, compounding weekly for 2.5 years, how much will need to be paid back? So this is only asking for the amount. It's not asking for the interest. And it says it's compounding weekly. So A, we don't know. Principal is 5,000. Rate is 0.035. T is 2.5. N is 52 this time because it's weekly. So we would do A equals 5,000 times 1 plus 0.035 divided by 52, all to the power of 52 times 2.5 to give us $5,457.05. So hopefully that gives you a little bit of an insight into compound interest and how it differs slightly from simple interest.